Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, Aaron Newcomb joins me. We're going to be talking about the cloud again. Cloudy, cloudy, cloud. Lots of cloudy shows. But this is a very important cloud show. It's talking about Kubernetes, which is a way to get your Docker containers to all talk to each other and deploy themselves and update themselves. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CACHEFLY.com.
This is FLOSS Weekly with Randall Schwartz and Aaron Newcomb. Episode 351, recorded August 26th, 2015. Kubernetes. This episode is brought to you by DigitalOcean. Simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code FLOSS in the billing section for a $10 credit. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at stonehenge.com, bringing you each week the movers, the shakers, the big projects, the little projects, the projects you may be using every day and not aware of it, projects you might want to go just download right after the show and start playing with it, because that's what open source is all about, tinkering with stuff, making things happen, making stuff happen the way you want it to happen. And I'm joined again this week by my lovely and talented co-host, Aaron Newcomb. Welcome back to the show.
Hey, thank you very much. Lovely and talented. That's nice.
Well, I try to load on these, you don't get paid enough, so I'm trying to load on the praise, hoping that makes up for the lack of money sometimes. But where are you speaking to us from?
From my study in my home. It's too early to come into the brick house, so you got me from my lovely study here. We have books in the background, and
you look so studious.
Where I do all my work.
You look you look like you might be brilliant if you've read all those books.
No, they're mostly my wife. She was a philosophy. She got her master's in philosophy, so she's got these philosophy books back here on the bookshelf. I haven't read any of them.
And did that help her with her employment at all?
No.
Cool. And for those of you who are watching the video, I am actually a brand new background. You've never seen this before. I was going to go to the place that has a nice green tree like I did last week, but they have their power out and their internet out. You can't do a podcast with no power and internet. So instead, I quickly ran the 6 blocks to their other building, the one I actually work in. And this is a nice little new conference room. If you can see the clouds behind me, those are the clouds of Santa Monica, slightly light clouds. And, everybody in Santa Monica hates it when there are clouds unless it's actually raining. So we don't know if these clouds are turning into rain today or if they're just going to be nice, pretty clouds that fade away. But that's enough. It isn't this week in Where the Hell We Are. It is this week in, nope, I did that before again. It's this FLOSS Weekly. We're talking about open source software. So today's topic is Kubernetes. Now, we had a little bit of Kubernetes in the show a couple weeks ago when we talked about Tectonic. And we have 2 guys on today to talk about Kubernetes that are more directly related with the project. We have Brian Grant and Tim Hocklin. And we'll bring them on in a couple of minutes. Oh, Tim Hawken, I'm sorry, mispronounced. I hate me for that now for the rest of the show. He can. It's okay. See, they let anybody do this show. Now, Aaron, you actually hosted the show where they did Tectonic and talked a lot about Kubernetes. Can you give us sort of the brief overview of it, probably even informing me because I didn't pay much attention?
Yeah, sure. So we talked to Brandon Phillips. If you missed it, you might want to go back and check it out. Well, we talked about Tectonic, which uses CoreOS, Docker, and Kubernetes to develop a whole container system for people that want to deploy applications in a very efficient manner. And so you might want to go back and listen to that. But Kubernetes basically is the container management, well, the way he explained it is it really allows them to be able to shift applications around, to have things operate dynamically, to be able to add containers, to remove containers, make things work really efficiently. And so we mentioned Kubernetes a lot during that episode because they really rely on it to make things work. And so it was just, by chance that we had these 2 projects on, not quite back to back, but almost, so that we can, it's nice because we talked about their system and what they're doing, and now we can actually dive into exactly what Kubernetes does and how it was developed and how it came to be and how Google's using it. So it should be very, very interesting.
Cool. And I'll obviously learn some stuff as well. And we'll just give you a moment right now to pause this show and go back and go get show 349 and go listen to it. Are you back? Okay, you're back. Great, thanks. Thank you for doing that. Okay, yeah, I'm looking forward to this, and because I'm all about containers now. We're trying to get that to happen at work, and I'm trying to get it even in my other client to be able to make it so I can use boot to Docker on my laptop and get the same exact bit for bit environment that we're going to eventually put in production. And so I'm really excited about what's been happening in the Docker community for the last year or so, and all the things that are building up around this, like Kubernetes. So, of course, we can sit here and talk forever about what you think it is, but it's probably better to talk to the experts. But we'll get to them in just a moment. I have a very important message before we do that. So whether you're an experienced code warrior or just getting started, you need flexible, reliable, and affordable hosting. DigitalOcean provides developers with Droplets, which are virtual private servers that can be customized and deployed quickly to host websites, web apps, production applications, personal projects, virtual desktops, and almost anything else you can think of with full root access. I myself am, in fact, a DigitalOcean customer. I found out about them back at Scale in February. They had a code that I could use to get actually a free couple months of use, and it was really amazing. I actually got a FreeBSD machine in the cloud in 55 seconds from entering all my information. It was really, really amazing. So DigitalOcean is built for developers and is used by over 400,000 of them, including me. You can deploy and configure your Droplets via a streamlined control panel or a simple API. You can choose your OS, and this is what I like about this. You can have Ubuntu, CentOS, Debian, Fedora, CoreOS, great for Docker, and FreeBSD. All the servers are built on hex core machines with dedicated ECC RAM and RAID SSD storage. Yeah, SSD, right from the beginning. Servers can have up to 20 CPUs, 64 gigs of RAM, and 640 gigs of SSD hard drive space. Auto backups and snapshots let you easily clone, deploy, and resize Droplets as you grow. Web console access with HTML5 plus SSH, SFTP, and KVM VNC for virtual desktops. And it's so easy to get started. You can deploy an SSD cloud server in as little as 55 seconds. DigitalOcean has incredibly affordable and straightforward pricing. Servers start at only $5 per month. There's also hourly pricing available starting at less than a penny an hour. Great for scaling solutions. But we're going to make it so you can get started today and deploy an SSD cloud server for free. Visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code FLOSS for a free $10 credit. That's enough for 2 months on the cheap machine. That's plenty to get started and explore what DigitalOcean can do. That's DigitalOcean.com. And once you sign up, enter the code FLOSS in the billing section for a $10 credit. We really thank DigitalOcean for their support of Floss Weekly and other programs on the TWiT network. And now let's go ahead and bring on our guests. Let me see where the names are. Right there. Brian Grant, welcome to the show.
Hi, good morning.
And where are you speaking to us from?
Mountain View, California.
Very cool. That's Google's headquarters?
Yes.
Very good. Yes. It used to be the SGI building. In fact, I taught many classes there when it was SGI. And so somebody invited me to go visit back. He went, hey, I used to teach right over here. And that was where the cafeteria was before. Really kind of cool. Anyway, okay, that's just me. Anyway, let's go ahead and also,
Some of the people here even work there for SGI.
Sorry. Yeah. Oh, really? Cool. Continue on. Let's also go ahead and bring on Tim Hawken. And I'm sorry for mispronouncing your name at the beginning of the show.
No problem. How are you doing?
Thank you. And you're near your buddy here, right?
I am. I'm about 200 feet from Brian.
Can you wave at each other, or you don't no visible?
No, we booked separate rooms so that we wouldn't crosstalk.
Oh, that's wonderful. Thank you. Sometimes we've had guests actually sit in the same room, and it's been sort of annoying. But thank you for doing that. I really appreciate that. So we'll go back to Brian here. Give us a 30,000-foot view. What problem is Kubernetes solving?
Kubernetes makes it easier to deploy, scale, and manage applications. But it's not a PaaS. It's more of a foundation for building PaaSes. In fact, OpenShift v3 was co-designed and co-developed with Kubernetes, and other PaaSes like Deis have ported to Kubernetes as well. So you could run your application on a PaaS on Kubernetes, or you could build your own custom PaaS on Kubernetes, or get along just fine with no PaaS. If you package your application in Docker containers, you can deploy it very easily on Kubernetes.
And you keep saying PaaS. Just want to make sure our audience is aware of what that means.
Platform as a service. Generally, a platform as a service system would make it easy to push code that then gets built and deployed and running in production.
Okay, what's your relationship to the project?
I've been working on the project from the beginning, and previously I worked on similar internal infrastructure at Google. There was the Borg project, which we use internally to run all of Google's applications like Search, Gmail, Ads, and so on. And a follow-on project to that called Omega, which I founded. And so Kubernetes, when we were discussing starting an open source project, made a lot of sense for Google to have its engineers who are very familiar with its internal, what we call cluster management systems, to work on Kubernetes and transfer our expertise to that project.
So is Kubernetes built from the ground up, knowing it was going to be an open source software, or was it sort of an adapt? Okay.
Yeah, it was built from the ground up, and that influenced some of the choices we made. For example, the choice of using the Go language to write the software.
Okay, I'm going to come back to you for more architecture stuff, but Tim, I also want to talk to you and ask you what's your relationship to the project?
Like Brian, I worked on our internal cluster systems, Borg and Omega, before. When we were having a summit with our internal teams and our cloud teams, and this topic kept coming up, and it seemed like such a good idea we couldn't not do it. So Brian and I were part of the original team that helped get this project off the ground.
Very cool. And so what is, can you describe then sort of, okay, so I kind of know what it's accomplishing for me, but how am I approaching it? What am I seeing when I'm entering commands or looking at GUIs and stuff? What does it actually manifest as?
Sure. Well, you mentioned that you and your clients are using Docker. You can't get too far into Docker space before you realize you need some help figuring out what machine am I going to run this Docker container on? What happens when the Docker container dies? How do I pull a new version of the Docker container? How do I grow the number of replicas that are serving this website? And you add all those things together, and they present a real problem, and that's the problem that Kubernetes tries to solve. Today you interact with it primarily through our command line. So instead of saying Docker run my command, you say kubectl create, and you give it some YAML that tells the Kubernetes system what to instantiate, which then goes off and picks a computer from your cluster, schedules the job onto that, schedules the job onto one of the machines in your cluster, manages it, keeps it alive, gathers logs, looks at statistics, those sorts of things. And then you can say kubectl get on those objects, and you can see the status.
And so one of the things I've always been curious about, because different people solve this different ways, is I'm deploying a cluster of related containers that like a web server, maybe 5 web servers, and then one database behind them or whatever. And you deploy it in like one machine on EC2 and another machine on EC2. How do they figure out the IP addresses of everybody they're supposed to talk to? Does Kubernetes help with that at all?
Sure. So Kubernetes has, if anybody who's played with Docker is familiar with the Docker networking model, which basically says by default, every container is private to a machine. And if you want to expose a container off of the machine, you end up binding to a port on the host. And you then have to share that information with the other containers as to what port am I on. This is actually what we do internally with Borg too. And it turns out it's actually really complex. So from the very beginning, Kubernetes has adopted the idea that container IPs are real IPs, and they're actually on the network as peers of the host, and that all containers on the network can talk to other containers on the network directly. There's no host port mangling. There's no NAT required for this, which has this beautiful side effect of if I tell you who I am, you can reach me by the same name, right? If I talk to you, my source IP is the IP that you can reach me back at. And so we do that, and then we add an abstraction on top of this called services because we couldn't find a more generic word. And a service is a collection of containers. We actually call them pods because they're small groups of containers. And it's a collection of pods that run, and a service gets a virtual IP. So now you can attach things like DNS to a virtual IP in a load balanced set without having to think about what's on the back end.
So again, I mean, it does sound a little complicated. You mentioned it was a complicated problem to solve. It certainly does sound like a complicated problem. But I think the goal here is to make it as easy as possible, correct?
That's right. I mean, it sounds a little bit complicated, but the first sort of tenet that you have to hold is that individuals don't matter so much and sets do. And so Kubernetes, the primitive is sets. So you want to think in terms of, Randall, you mentioned your 5 web servers. Those 5 web servers are essentially fungible, right? And you just don't care which one you pick. You just got to get to one of them. So that's the abstraction.
So that simplifies things even just in the architecture of how it works. I also wanted to ask you before we get too far in, where did the name come from? Because, I mean, I know when I first looked into this, I had trouble just pronouncing it. So I'm just kind of curious, what was the origin? What's the superhero origin story of the name here?
There's the origin story is not nearly as exciting as the root of the word. The word itself is Greek. It means the helmsman, or the guy who drives the ship, right? Docker and everything has stayed with a very nautical shipping container sort of theme. So we wanted to stay with the theme. But the word Kubernetes is actually the root of words like governor and cybernetic. So it's actually got sort of a cool meaning.
And what's the give us a little bit more background on the origin of the project itself. I mean, you said it grew out of some other things that were going on with Borg and Omega, and I believe you said those are Google's internal systems that they use. But I mean, how did it actually come about? I mean, how old is the project? Was Docker first, or did this come out after? I mean, containers have been around for a long time, right? I mean, I know back at Sun we were using container technology as opposed to straight up virtualization hypervisor technology for a long time. So I'm just kind of curious, when did this get started, and has it always been related to Docker?
So Google's been using containers for a very long time. We sort of skipped the VM stage and just went straight to containers. We're right that places like Sun have had it even longer than that. This project in particular started about a year and a half ago, when we were looking at our internal infrastructure and our cloud infrastructure, which are sort of common at the very bottom but diverged near the top of the stack. And we're building a lot of ideas twice because we needed one for cloud and one for internal. And we sort of got some direction that it'd be nice if we stopped building everything twice. And so we spent some time thinking about how could we do that, what would be sort of a unifying platform for these things. And then at the same time, Docker landed. It sort of leaked as part of a talk that I think Solomon did, and it turned out that nobody was really interested in the rest of the talk except the Docker part of it, and that has turned into sort of the biggest snowball, maybe the second biggest snowball the world's ever seen. And at the same time as we were looking at these plans, we saw that Docker was happening, and realizing the world is catching on to the idea of containers, which we think is fantastic. And this is when the pieces started to fit together. Wouldn't it be neat if we took what we know about containers and Borg and what we've done with this stuff, and we took Docker and the experience they've got with a really streamlined developer flow, and glued these things together and took people to the next level of managing software.
So has Kubernetes now replaced Borg and Omega, or what was going on internally, or are they still separate platforms?
They are still very much separate platforms. Tens of thousands of applications run on Borg and Omega, so it will take a long time to transition those. Right now, we're entirely focused on serving the needs of the community and external users and our cloud customers with Kubernetes. And our goal is to make it as good as Borg at serving and being able to run the same diverse set of applications as Borg, but focus really on the needs of the external community, which is very similar in concept and in patterns, but different in a lot of the details. Internally, Google has an ecosystem that developed just within Google that's different from the kinds of software, the specific applications that people use outside of Google. So, for example, outside of Google for web servers, people use Nginx, HAProxy, Apache, so on. And internally, we don't use any of those. We wrote our own.
Right.
We also sorry, go ahead.
Go ahead.
We also internally we have control over these things, right? I can call up the application developers and say, hey, you need to adapt to this new piece of infrastructure, or we're taking away this core functionality. You need to adjust. And we entered Kubernetes with the idea that that's not possible, right? We have to meet people where they are today with what they're doing today, even if we think that what they're doing today maybe isn't best practice for some of the patterns that we've established at Google. And that has really shaped a lot of our decisions. I mentioned the virtual IPs is part of that. Internally, we do port mangling because it's built into our RPC library. Externally, we just can't do that with people.
So how does that feedback come back to you? You say this is really, meant for the community. It's meant for, I guess it's almost better to say external things that are going on as well, right? Because you said you use it for Google Cloud. So how do you get feedback back from the general community to say, hey, this isn't working, or I'd really love it if there was some sort of node management or better node management, or how do you get that feedback?
We
Mostly,
actually
go ahead.
Yeah, we have several channels by which we get feedback. I mean, first of all, we're working with outside partners like Red Hat, who has a lot of enterprise experience, who bring some of the experience with these external users to the project directly. And we also interact with the community through IRC and Google Groups, Stack Overflow. It's pretty easy for people in the community to reach us.
And you said that this was being used for the Google Cloud, their public cloud services. I mean, I spun up a LAMP stack, for example, the other day on Google Cloud, and there's lots of different things you can do with it. We don't have time to go into everything, but I just wanted to start something up so I could play with it a little bit and see how the how the management interface worked than the actual service. Was I using Kubernetes then, or when does Kubernetes come into play? Do I have to go in and select specifically, like use Kubernetes and then go deploy my application to all these different containers, or how does it know when to use Kubernetes? It seems like it's more behind the scenes.
So we have a separate product alongside Container Engine. We have, alongside Compute Engine, we have Container Engine, which we call GKE, not to be confused with the other GCE. GKE went general availability today, in fact. Happy coincidence. So the way you use Kubernetes on Google Cloud, the simplest way is you go to the left bar in your Cloud console, you go to Container Engine, you say, create me a new cluster. You tell it how many nodes you want and how big of a node, and it will spin up that cluster for you. And then you can use our kubectl command, kube control, to launch jobs into Kubernetes on GKE, just as if you had your own Kubernetes cluster. If you don't want to use the hosted version, GKE, you can download the Kubernetes code, and you can build it and push it out to GCE yourself. We have a bunch of shell scripts and set up in our code base that makes it possible to run on GCE directly. The advantage of GKE is that we will host your master for you. We'll manage it. We'll deal with the availability. We'll deal with the upgrades, those sorts of things.
Right, which is exactly what you want in these types of cloud hosted services. So that's fantastic. And I'm going to be trying that out. I'm going to go maybe while we're talking here, as soon as I pass it back to Randall, maybe I'll go try that out and see if I can find it in the admin interface. We do have a question from the chat room, and we like to get these in whenever we can. Sandman says, can you use one admin interface to control clusters located on separate cloud providers? So if I've got clusters maybe on AWS and Google, can I use one admin interface to control all of it?
You can. Our kube control command line tool can be used to talk to any number of clusters. All you have to do is issue a command to switch your context from one cluster to another cluster. So each cluster you would interact with individually right now, but it's very easy to switch back and forth between clusters. I mean, generally, users want to deploy different things to different clusters. For example, they may have a development cluster and a production cluster, or they may have very specific applications they want to run in their on-prem cluster versus their public cloud cluster.
Fascinating. Hey, so can I easily migrate then from, say, if I put it up first in GKE, and then I decide, no, I really want to host my own bare metal? Is this going to be easy to migrate? I guess the back end's got to be pretty transparent, right?
That's right. I mean, you touched on a big selling point of Kubernetes is your applications should not be coupled to the cloud platform that you're running on. This is a real problem for a lot of people today, that they develop roots that they didn't really even realize they had, and then when it comes time to unsingle source themselves, they're stuck. So Kubernetes really gives you an abstraction that you can build to that is really cross-provider capable, and provider here can include bare metal.
And I know that's one of the big selling points of OpenStack, and one of the reasons the unification of OpenStack has been really important all across the different providers and stuff. Actually, I think there's 2 or 3 projects in that area that's basically say you can run bare metal or you can run in the cloud. It doesn't really matter to us. The software still looks basically the same. So what's the minimum sort of deploy that I would reach for Kubernetes as opposed to just simply saying Docker run on my host?
I mean, if you have a job that you want to have multiple replicas of for scalability, you can run Kubernetes on a single machine, on a master plus 1 node, or you can run it on up to we've done a couple hundred, but we support up to 100 nodes. So there's no, I don't want to say there's a bottom limit. I mean, obviously, if you have just a single Apache server, maybe it might be overkill. But if you feel like you might need to scale that Apache server and start handling more traffic, then Kubernetes is a great way to sort of get in there and start that already.
Yeah, and if you want to make it easy to update your application, or you don't want to have to worry about your individual machines or VMs going down, and you want your application to still run, Kubernetes just generally makes it easy to deploy and manage your application that's packaged in a Docker container. So if you're serious about running your application and keeping it up, there is really no bottom limit to how few machines, maybe more than one, but even with just 2 machines, I think it actually makes managing your application easier.
And to be clear,
go ahead. Sorry.
To be clear, the container engine model on Google is in fact free for less than 5 VMs. So if you just want to have 1 VM running in container engine, you don't need to pay for the master at all. You just pay for the VMs that you use up to 5. Beyond 5, there's a nominal charge of $0.015 an hour or something.
Now, by VM, do you mean container, or do you mean something even at a lower level?
In this case, we need machines to schedule containers into. So you provide a pool of VMs in GCE. It could be physical machines if you were running in your own data center. You provide a pool of machines, and the master will schedule into those machines.
But I could have, for example, if I have a web container and a database container, they could both go into the same VM?
Absolutely.
Ah, wow. Now, how complete is this solution? I mean, is it also taking care of, watching the load average and firing up new machines if it needs to, or doing load balancing across, with one outside IP going to multiple internal machines? Does it do all of that, or do I still need other pieces to make this solution work?
No, it does a lot of that. We have auto scaling working. We've demonstrated that in our, it's not in our 1.0 release, it's in our 1.1 upcoming release, where you can tie into Google's cloud autoscaler, and it will dynamically add and remove machines based on your CPU and memory utilization. We have external load balancing that works across machines fine, up to hundreds and hundreds of backends. We can support thousands of containers running in a single cluster. If the nodes die, the jobs on those nodes will time out, and we'll move them to new machines. It's a pretty robust system at this point.
Wow! It sounds like I want to write something that needs scaling. I'm going to go write the next Twitter now. This is my goal for today. Not really, no. But this would be great for something like Twitter, right? Because they could just keep, they could start out small, and this would just automatically help them ramp up, right?
Yeah, exactly.
Sorry, I didn't address that to either of you guys. Somebody answered. That's cool. So you keep talking Docker, but there's also other container formats. I think like Rocket is the one that the CoreOS team is coming up with. Does Kubernetes work with that?
It does. Kubernetes supports Rocket, and when the Open Container spec is ready, we'll support that too.
Very cool. Actually, we had a great Docker episode, and we've talked to Docker about 4 or 5 times in previous shows, but maybe you could explain just a little bit more, because I know we had a lot of questions in the chat room just before the show started about what is a container? How is it different from running a full VM? Somebody want to take that?
Sure. A container, the general answer is it's a very lightweight VM is sort of one way to think of it. It uses Linux primarily, although people like Joyent have made the Docker model work on non-Linux machines, which is interesting. And Rocket supports others like BSD. But you take a Linux machine, and instead of bringing up virtualization, which has some amount of overhead, you bring up OS-assisted virtual machines, if you sort of squint at it. In Linux, that involves namespaces and C groups and chroots, which you build together to give you the semblance of your own private machine, with limitations on how much memory you can use, with restrictions on what you can do with the CPU, and what you can see in the file system. In a sense, you've got a VM without the overhead of VMs. It's not exactly a VM in that it doesn't engage the virtualization hardware, all the nice stuff that Intel and AMD have baked into their processors over the last few years. But it doesn't really need that because it's just running in the OS. So you get better performance, you get lower overhead, and you get simpler to manage applications. The big win here being visibility, right? Inside a VM, if I'm a host machine running a VM, I can't see what's happening inside that VM. It's completely opaque to me. Whereas if I'm a host machine running containers, I can see what processes you're running. I can see what your load average is. I can see how much memory you're using. I can see how much disk I/O you're using, and I can manage those things.
You can manage those things. Sorry, I was drinking coffee.
Sorry.
You can manage those things. Can you also deliver quality of service? I mean, if you've got several containers running on one, and I know this is a little bit what we talked about last week with Tectonic. I'm just kind of interested to get your take on it. So you're building the system, and maybe you've got several different applications running in different containers on the same VM or even the same physical hardware. How do you load balance those things? How do you deliver a consistent quality of service to an application? How do you make sure that you're not going to run into bump into the other applications who's also demanding a lot of resources from the physical hardware?
Yeah, absolutely. We can deliver quality of service. This is how Google runs all of its applications internally, and its applications have very stringent performance requirements. The Linux kernel provides a number of mechanisms that can be used to provide isolation between different processes. C groups is one of the primary mechanisms for this. It can be used to constrain the amount of memory or the number of CPU shares that each set of processes and controlled by one of these C groups can utilize. You can also apply additional mechanisms like allocation of individual CPU cores to specific sets of processes. You can prioritize which processes get killed when the system runs out of memory. So actually, it's a lot of the Google runs its cloud, Google Compute Engine on top of containers running on Borg. And it's actually these primitives in the Linux kernel that containers use that provide a lot of the performance isolation. So in the upcoming Kubernetes 1.1 release, we've introduced a quality of service abstraction in Kubernetes that allows you to distinguish between containers that need a guaranteed level of quality of service for CPU or for memory, but also lower levels of quality of service. For example, containers that need to burst, they need a reservation on a minimum amount of CPU or memory, but they need to be able to burst above that, or best effort containers that just want to use whatever they can get.
Oh, wow. Fantastic. That's a lot better than I had hoped for. That's really, really cool. How is this different from what I mentioned this before? When I was at Sun, we made a big deal about our container system. I think it was introduced maybe in Solaris 10 or thereabouts. And you may not know the answer to this. I'm just kind of curious. How is it different from the work that we were doing back then? How does the new container, especially with Kubernetes, differentiate itself from? Because I was talking to someone at work, and we both come from Sun, and we're doing a lot at work around Docker and containers and Kubernetes actually, and we were talking about, it's like, man, this seems like deja vu. Like we were talking about this, 10 years ago or something, about this new thing coming up called containers. I mean, how is it different from the way Solaris did it back then, if you know?
So I also came from Sun many years ago, and the difference is mostly in the implementation. I mean, Solaris zones are an OS feature that was built into Solaris many years ago that really solve the same sets of problems that namespaces and C groups in Linux now solve. They solve them differently, and depending on who you ask, one is better or one is worse. But I think what's changed is people are ready for it. People tried VMs, they used VMs, they made great hay out of VMs, but they also realized the pain of VMs, and people have gotten to the point where containers are ready, right? Like I said earlier, Google's just skipped over VMs. We never saw the need for it. Part of that was we had people who had experience with things like zones, who said, this is a better way of working. It's more efficient. And efficiency matters when you're talking about Google, which has, let's just say, a lot of machines. Squeezing a few percent out is a big deal. Other people are starting to catch on to this. And I think that's fundamentally what changed right now is the ecosystem is ready for it.
Interesting. I know a lot of what Sun was using it for back in the day was they had this upgrade promise. And so one way for them to fulfill their promise of always having your app run in Solaris was to put it in a container and having it run on a different, or a zone, and have it run a different kernel, a lower grade version of Solaris or something like that.
Exactly.
So it was a big way for them to get around their upgrade guarantee,
Sure.
which is kind of interesting.
One of the big things I think that's changed now too is API. We're not talking about giving users zones and an OS and go play. We're talking about giving users an application-centric API. And this is really where I think Kubernetes is different than other things in this space, is it's not just about getting access to infrastructure. We're actually providing primitives that are focused on and geared towards application management. And the way we do deployment, the way we do updates, the way we manage relationships between things is really focused on building a distributed application, not here's a bunch of machines, have fun.
Yeah, definitely. There's a question that came in from the chat again. Sandman in chat says, does it currently work with Azure, which is, of course, Microsoft's cloud platform, or do we have to wait for the next update to Azure that supports Docker? And likewise, I was reading the press release, and I don't know if John has pulled that up yet again for us before, but I was reading the press release, and as I scrolled down, I noticed it says that you've got Red Hat, Microsoft, IBM, a bunch of different players that are using this. I didn't see Amazon Web Services in here. I know we mentioned them before, but so I guess that goes along with the same question. What about Azure and Amazon AWS? Or what's the support level between the different cloud providers for Kubernetes?
Sure. Absolutely, we run on AWS. It's one of our supported platforms. There are turn-up scripts built into the code base. If you just set your cloud provider environment variable to AWS and say cube up, it will bring up an AWS cluster. We do support Azure in Linux Azure, but not Windows Azure. I know Docker and Windows are working hard to get that stuff working. We haven't really entered that space yet. It does support Azure, though it supports it in one mode with CoreOS, I believe, and people are actively working on updating support for other OSs on Azure.
Awesome. Hey, Brian, what are some examples, if you can share? I know there were some in the press release, some customer quotes and things, but what are some examples that you might be able to share with us around how customers are actually using this, and especially if there's a particular business benefit that they see from using Kubernetes? Or if Tim, if that's not the right, you can answer. But I thought we'd get Brian back in here to talk a little bit. So, what are some examples of customers that are using this today?
Well, you saw there in the press release that was brought up that Porch is using this to run their storefront, their online storefront on Kubernetes. We had a number of customers talk at the Kubernetes launch about a month ago in Portland. Shippable is a CI/CD system for building applications. In fact, we use Shippable for the Kubernetes project itself to build Kubernetes. When people send changes to the Kubernetes source code, we want to build those immediately, test them, make sure they work. Shippable does that for us. They actually run on Kubernetes now. They run their builds on Kubernetes, and they also provide a feature that allows their users to automatically deploy onto Kubernetes after their code is built by Shippable. So there are a number of use cases, web serving, CI/CD. People are starting to experiment with running big data applications on Kubernetes, and that's something we're going to be focusing on in the near future. Not a lot of people, I think, are running storage systems or databases on Kubernetes quite yet, although we do support containers mounting network attached storage from a variety of storage backends. But that's another class of workload that's going to be better supported in the future. There's really no type of application. If it runs on Linux, it will eventually run very well on Kubernetes.
So let me just follow that up. I have to jump in since I'm a storage guy. Is that something that people are doing today, or is it possible to do with Kubernetes, which is if I have a container and maybe I'm in a development environment, let's say, and I need to make a copy of that for somebody else, or a copy of the environment for someone else. How do I do that today? And is that something that it would be useful to? I'm thinking of like our snapshot technology and things like that can make really quick copies of volumes and LUNs, but also if there's a tie-in to Kubernetes, maybe there's a way to make that happen really quickly too. Does that happen already in Kubernetes? Is that something that already exists?
This is not something that exists yet. We've spoken to a lot of storage vendors and people who are interested in storage. We do not yet have a sort of automatic backup or automatic snapshotting system. That said, I'll put a plug in for our friends at Cluster HQ who have a product called Flocker, which if you haven't had on the show, you probably should. And Flocker manages that sort of stuff for you. I was speaking, in fact, just yesterday with some of the guys there about making a Kubernetes plugin for Flocker so that you would be able to have your containers run against a migratable storage backend that was managed by Flocker. How's that for integration?
Exactly. We're working with Flocker too, so I'm glad you brought it up and I didn't have to. But yeah, some really cool technology that they're working on for sure. And we're working on it with them as well to integrate some of that into what we do at NetApp. Really.
I would just add to that Kubernetes supports, as I said, a number of storage backends. For example, on GCE, we support Kubernetes will automatically mount persistent disks from GCE into your Docker containers. So since GCE persistent disks support snapshotting, you can very easily use that underlying feature from GCE, and then launch new containers that mount those snapshots.
I think this is the first time on this show that I've been listening to acronyms and technologies and jargon and not actually understood everything you guys were just talking about, but that's okay. I'm a programmer. That's what I do. So I also have a question, though. You mentioned all the different places that Kubernetes can talk to. I'd like to develop on my laptop, and I've got boot to Docker. Will it know how to talk to that?
I believe the answer is yes. I do not have a Mac myself, Linux through and through, but I believe that it will work. It certainly works with Vagrant. We have a Vagrant installation, so you can spin up VMs locally with Vagrant and manage a virtual cluster. We also have a way to just do a local cluster. If you're on an airplane and you want to do some testing, you can spin up a master and a kubelet all on your laptop together. It's sort of crippled in that there's no network, right? But it's fine for doing things like testing out. And certainly we support local things. Vagrant is the one I know best. Brian, I think you have a Mac, right? Do you ever do local work on it?
I have a Mac. I've never used boot to Docker. I actually do all my work on Kubernetes completely in the cloud. It just makes it a lot easier to create the size, number, and type of resources that I need for whatever experiment that I'm doing. Laptop environment, can be used for simple build and test, but most of the kinds of work I do require more resources than what I can do on my laptop. That and Chrome takes up all the memory on my laptop anyway.
Amen.
Yeah, well, I'm asking this because I computed since 1995. I spend an hour a day on the average in the air, and I spend 7 weeks a year on cruise ships. So the connectivity in both of those is pretty limited, and it'd be nice to develop my primary client, my primary client, because I've had them longer, their software while I'm sort of semi-offline. So that's sort of the curiosity I had there. We also, so you've mentioned master a number of times, and I'm wondering, failover, high availability, is there just one master, or can we have a pair of masters that are watching each other, or what's the scope on that?
Yeah, so Kubernetes by default runs just one master. A lot of people run small clusters, and the master requires one VM. So, but we do actually support high availability. Kubernetes stores its state in a program called etcd, which is a key value store, actually developed by our partners at CoreOS. And you can run etcd replicated so that if one of those etcd instances is lost, the quorum of the remaining instances can still keep the state of the cluster. The other components of the cluster level control plane, which we call master as shorthand, can also run replicated. Our API server, the scheduler, our other controllers, and so on that manage all the containers running the system. So yes, we do support high availability for people who need that and for larger clusters.
Okay, just kind of change gears a little bit to something I can more relate to. Go, the language Go, developed at Google a while back, and you chose to use Go for this. What was your reasoning with that?
So when you look at the sort of ecosystem of languages in the system space right now, which we did at the beginning of this. I mean, Google is a big C++ shop, and I was a C++ programmer before this. There's not really a great open source community around C++. There's not a lot of great. I mean, you're hard pressed to point to more than a few big successful open source projects that are written in C++, and it raises the bar for contributions, quite a lot. And so we sort of ruled out C++ based on that. I argued against it. I was wrong. Then we look at something like Java, and we didn't want to deal with JVMs and the overhead of that. So then you look at languages like Python, and you just don't. I mean, Python's great, but it's not for big systems like this. And so we were left with, we could do it in C or we could do it in Go. People have been talking a lot about how much they like Go. The Go team sits downstairs from us, so if we have questions, we can go talk to them. So we tried it out. For all of us, I think everybody on the project, maybe minus a couple, this is the first time we've used Go. So we learned it as we went. Some of that is reflected in the code base. But we're a year in, and as much as I love to rant about things that Go does wrong, I would make the same choice today. It's a good language for just slamming code out, getting things done. It shares some beautiful parts of C that, like there's one way to do a lot of things. Unlike C++, you don't argue about, do I pass a pointer or a reference? Should I use value? Should I use ownership? Go just has a way of doing things that is simpler. And so I think it's been a net win for us. Also, Go has a really, really vibrant open source ecosystem. There's a lot of libraries. There's a lot of people who are really passionate about Go. And so it's been a real win for us.
And sorry, I just got a little throat there, a little bad throat. So apparently Kubernetes just hit 1.0 real recently. What was involved with getting that going?
So our 1.0 release was, sort of a rally point. We picked what we thought our goals should be for reasonable scale, for reasonable workloads, the sort of things we wanted to handle. And we focused on those things to the exclusion of a lot of stuff. I mean, the truth is there's a million things we want to do. Brian says we've got 10 years of work to do. And he's probably off by half. We want to work on everything. We're all excited about everything, but we had to choose which things were going to be important. So we focused on website applications. We focused on moderate scale, on the order of 100 nodes. And those are the things we really focused on. It was a lot of fleshing out the feature set, which our partners at Red Hat did a lot. They brought a lot of interesting experience. We should talk about Red Hat some more, that relationship. But it was a collaboration between us and them and a lot of open source folks to define what was in and what was out. And if you looked at the GitHub logs in the last month or two of our development cycle, you can see us drawing the line and telling a lot of pull requests like, thank you for the pull request, but this is out for 1.0, and it's not going to make it.
And so, Brian, apparently you're aware of things that are going to go be in, going to be in Go in the future. Wrong. We're talking about Kubernetes. Kubernetes in the future. You want to talk about some of the directions Kubernetes is heading?
Yeah, as we've talked about a few times, we're working on a 1.1 release. We're shooting for October for that. It will add quite a number of features, including the quality of service functionality that I mentioned before. We're also aiming to broaden the set of workloads that Kubernetes runs really, really well. You can do anything in Kubernetes right now, but some things are harder than it should be. So we're focusing on usability. We're taking some of the operational features like rolling update, allows you to update your application one container at a time so you don't take down your whole application when you want to upgrade. We're taking that and putting that into a service that runs server side. We're going to make managing application configuration easier. So more work is being done all over the system. We have the auto scaling Tim also mentioned before. It's going to be in 1.1, both auto scaling of the cluster and auto scaling of pods and containers running on the cluster. As Tim said, we focused initially on web serving workloads. We're going to make those even better with support for L7 load balancing and HTTP-based load balancing and big data applications and a broader set of applications. So, as Tim said, I always say that we have lots of years left. Borg is about 12 years old, and still new, useful, interesting functionality is being added to Borg all the time. So Kubernetes definitely has a long way to go. We are getting a lot of help from the community. I think we have almost 500 contributors now. But it still takes a long time to, even with merging 40 or 50 changes a day, to review all those changes and evolve the system in a way that now that people are relying on it in production, keeping it stable, making sure that we maintain backward compatibility, all those things that users who are depending on it care about.
Cool. I know we're almost out of time, but I did want to come back to something that Tim said, and that's the Red Hat relationship. I think you mentioned that they're using this for their OpenShift platform that they acquired a while back. Can you explain a little bit more about the Red Hat relationship real quick before we wrap up?
Yeah. So at DockerCon 2014, when we announced Kubernetes, and everybody and their brother announced their own cluster managers, we met up with a fellow from Red Hat who had been working on their Project Atomic, and we had looked at some of their work while we were figuring out what we were going to be doing and how to do it. And we discussed with him what we were up to, and he got a little bit excited about what we were doing because they were building the next version of their OpenShift, and they wanted to focus on Docker. But they were sort of daunted by the idea of writing a whole cluster manager. That's not the business they wanted to be in. And we sort of want to capture the mind share of people like enterprises, but that's not the business that Google is in, right? And so it seemed like a reasonable place to collaborate. Well, that fellow turned out to be Clayton, who is now our number 2 or number 3 contributor on the entire project. So Red Hat made a large commitment to go all in on Kubernetes as the substrate for building their OpenShift platform. So OpenShift 3 is entirely based on Kubernetes. It does not hide Kubernetes. It exposes it clearly, and then it builds on top of it. So they've added some new primitives that are higher level platform as a service. And over time, they've been sort of porting those things upstream. They've been offering us a lot of ideas. But they also work with us to design core features. They propose new ideas that will enable things that they want to do. They help us to make sure that we capture the enterprise use cases, places where we don't have a lot of experience. And enterprise is obviously very different than cloud native. So the relationship has been really pretty fantastic. They've got more than a dozen engineers like full time on this project. They are probably 40 or 50% of the system is designed by Red Hat, and Google in collaboration. The other, 50%. It's one of these interesting cases where two commercial companies can contribute to an open source project and really find win-win. I think it's a really interesting relationship.
That's very awesome. I'm just chatting with Erin in our back chat about how I'm getting really excited about this, and for me, I'm getting the impression that Kubernetes now, with the adoption by like OpenShift and other players, and also with Google behind it, it could be the equivalent of what, let's say, OpenStack was 5 years ago. That once it came out, everybody was going, "Oh yeah," and they all started like either conforming to it or adopting it, one way or the other. They kept saying we're compatible with OpenStack or we're using OpenStack. Do you see this similar with Kubernetes?
You want to go, Brian?
Okay.
Yeah, Brian.
Yeah, I'm sure. We really hope that that will happen, and we do see that happening already to some degree in the platform as a service space. Where, as I mentioned, OpenShift was co-designed and co-developed with Kubernetes and really integrated. It's really a seamless extension of Kubernetes, but other platform as a service systems have also ported, like Deis, and others are investigating doing that. So we see more and more traction all the time.
Very cool, very cool. Well, we're almost out of time, as Aaron said a couple minutes ago. But is there anything I didn't ask that you want to make sure our audience is aware of before we have to let you go?
No.
Try it out.
Yes,
Try it out. Okay.
Try it out. Whenever we talk about this, we make a point that there's two parts of the Kubernetes problem. There's setting up your cluster and there's using the cluster. The setup is really the not so fun part. And unfortunately, it's required to get to the using part unless you try something like GKE. So if you're interested in Kubernetes and you just want to try it out, a great way to get started is to go to Google Container Engine. You can spin up a less than 5 node cluster for free. I think if you're a new user to GCE, you'll even get a few $100s of credit to join GCE. So you can really try the thing out for free. And then if you like it, then you can sort of cross the mountain of setting it up yourself.
That sounds awesome. In fact, if in my copious spare time, which I always say right after every show, or always say at the end of every show, I'm going to go play with this. I will going to go play with this because, again, it can be very important for both of my primary clients right now. I really would like them to move to this solution instead of the weird solutions that we have set up for ourselves already. Well, guys, I got 2 important questions I have to ask both of you, or I get email about it. So we'll go with Brian first. What's your favorite text editor?
Emacs.
Yay! Yay! One from my side. Thank you for liking Emacs. I never get enough people say Emacs anymore. It's a small subset of the general population now. And your favorite programming language?
I don't know. Good question. I don't really have a favorite. There are some things, as a former compiler and language kind of guy, I respect a lot of the way Go has decomposed a number of the language concepts. Mm-hmm. So since we're using Go for Kubernetes, I'll say Go.
That sounds great. Yeah, I was thinking, sort of reading your mind there, I was thinking maybe it's like whatever gets the job done, because I know I use a dozen language over my career, so probably something like that. So, and Tim, the same 2 questions?
Vim, clearly.
Yay.
And in terms of programming languages, I have a love-hate thing with Go. I was a C++ fan, and I still sort of pine for some of the power that C++ gives me. But, Go is easier to get stuff done in.
Awesome. Well, guys, it's been wonderful having you on. I'm sure there will be a lot more people interested in what Kubernetes has to offer, thanks to your conversations with us today. And I really appreciate your wonderful answers. Thank you.
Thanks.
Mm-hmm. Thanks a lot.
It's been fun.
All right. That was Tim Hawken, Brian Grant, both from Google, talking to us about Kubernetes. What do you think there, Aaron?
Well, I'm excited about it. I mean, and this is something that I've been researching for a while. In fact, I just had a conversation with someone internally at work about this. It was earlier this week, last week, I guess, because I got so excited from the show that we did with Tectonic and CoreOS, and then started talking about Kubernetes. And I'm like, oh, Kubernetes is coming up in a couple of weeks. I'm so excited. I got to ask him a lot of questions. So it is. I mean, this seems like I think you alluded to this. It seems like an infrastructure changing type of way. And it's not just Kubernetes. It's containers as well. But it just seems like we're evolving past the point. First we had, everybody runs on their own server. Then with virtualization, you can kind of combine workloads and change things up in interesting ways. And now for applications, not infrastructure, but I think for applications, Kubernetes and containers really adds another layer to that. And yes, it has to do with infrastructure as well, but infrastructure is being obfuscated a little bit, especially when you talk about, hey, I can run this workload in on-prem. Maybe I share a little bit of that workload with the cloud somehow, or maybe I run in multiple clouds. I know that's really interesting to our customers as they try to choose. Like, what if Amazon AWS goes down or starts offering, raises their prices or something? You can just move over seamlessly to Azure. So there's tremendous amount of business benefit to this type of thing as well. And so I really see it as maybe not game changing, but it's certainly game evolving.
Yeah, and I keep seeing these different layers as well. Like, you spell it pretty well, but like bare metal sitting in my office, bare metal rented in the cloud. Things like EC2 came along, and then everybody was sort of a different platform. And then there were like other people that to try to be the people to pull across from EC2. They created interfaces that look exactly like Amazon Web Services APIs. So they could, claim portability, and that sort of created its own standard. And then we got to this whole OpenStack thing starting 5 years ago, where we had this and a couple other platforms sort of in there, but basically unifying the next layer up. And then now we're getting Kubernetes, which is giving us the ability to orchestrate all these things. I know Weave, we had those on about 2 or 3 months ago, and I forgot to contrast this with Weave, but maybe some other show we'll do eventually talk about that. We'll talk about all the different things that are sort of like Kubernetes and put them all in one show. And then it's like every time we're like turning 45 degrees. But I think we're eventually now heading pretty close to the target. And who knows what's going to happen 5 years from now? Maybe it'll all be just AI, and you'll just say, I want a web server, put it there. It'll be like, the future crime, thing, whatever that show was called. Right. Just put it up there, and then put that over there, and just work it out that way. Anyway, pretty cool. All right, almost out of time, so we'll probably just stop rambling on. Let's talk about who's coming up next. Next week, we do have another show that I am hosting from my home, actually. So hopefully my home network will work. Now that we have the hardwire, it does make it a lot better. It's FWNOP, FWKNOP. Port knocking, next generation single packet authorization. We have Gambus, which is free object-oriented basic inspired by Visual Basic. That ought to be interesting and cool. We have Ichinga, which is a fork of Nagios. That's a scalable and extensible monitoring system. If you're familiar with Nagios, Ichinga started out being exactly the same. It's just a fork. And then they started taking it in really nice, unique directions. So that's a lot of fun. We're actually running Ichinga here at the client I'm sitting at, Dart, ZipRecruiter, by the way. I should mention the name at least once since they're giving me office space. And after that, we've got Dart. I'm really looking forward to that show because I gave a talk on Dart a couple months ago down in Porto Alegre, Brazil, and it's also something I'm really looking into in terms of being able to teach and write books about and write magazine articles and all sorts of things. So we've got the head of the project, Casper Lund, and one of his cohorts, Anders Sandholm, coming in to talk about that. Just added to the schedule. I opened up about 10 more dates that I could see in my future schedule that I could plug in FLOSS Weekly things to. We've got Crowd Supply. They're an open hardware marketplace. And I know, Aaron, how much you like open hardware, so maybe we'll bring you on as the co-host for that. But and do you know about Crowd Supply?
I do not, so I'm going to go look it up right now.
Okay.
Sounds great.
Okay. But they approached me. It's really great. Again, all these people got on the show, almost all these people got on the show, by having, somebody... One of you listeners or viewers said, I wish this people were on the show. And then you go talk to the project leader and have the project leader email me, merlin@stonehenge.com. If you forget that email address, it's right on the homepage for this show, twit.tv/floss. There's also a link from there to the big magic spreadsheet that we actually do the internal scheduling with. So you're just looking at a couple columns out of the 7 columns we actually have internally for that spreadsheet. Thank you, Google Spreadsheets, for letting me do that. And then we have a live stream. We had a number of questions this week from the live stream. We tape at 8 o'clock a.m. Pacific time on Wednesdays. Currently GMT -7, but in the winter it'll be GMT -8. You can follow us on FLOSS Weekly and Google+, which also maps over to FLOSS Weekly, the Twitter handler, all one word. And that will break in about 3 weeks unless I can figure out a replacement for Yahoo Pipes. If anybody out there has a great replacement for Yahoo Pipes that can hit an API and generate an RSS feed, I need it now. I need it, otherwise these feeds go away. You can also follow me on Google+, Randall L. Schwartz, and that also, for the next few weeks, gets mapped over to Merlin, MERLYN, on Twitter handler. I'm going to be at DragonCon next weekend. That's the big science fiction, fantasy, and everything else conference, and in where was it? Atlanta, Georgia. Atlanta, Georgia, in the fall. Imagine that. Well, actually, late summer. It'll just be hot. I just know it will be. I'll be actually speaking on 4 panels. Ingress. I'm going to be talking about the game, Google's game, actually now spun off to Niantic, and how much I play it, and what there's behind it. Apparently, that's a fairly popular panel. I'm also going to be on PGP 101, how to protect your stuff. Now that Edward Snowden says everything is exposed, how do you actually have private conversations? We're going to actually be giving some talk about that, taking Q&A on that. I'm also on the traditional Hacking 101 and 201, where it's basically Ask Me Anything. So awesome stuff. I think that's my only plug for right now, but basically I'm just taking the rest of the year off. No more conferences, no more, but I am doing a cruise on my birthday week. November 22nd is my birthday. I'm going to be out on a cruise ship actually in Mazatlan on my birthday. That should be pretty cool. All right, that's enough for me plugging. You want to plug anything, Aaron?
Yeah, sure. I got a couple of quick things. Number one, if you're like me, I'm trying to get my kids into coding and teaching them. We talk a lot about different programming languages and different, the various differences between Go and C++ and Java and whatever else your favorite language is. But it can be kind of hard and overwhelming to get kids, especially into coding. And I know Code.org has done a lot of stuff and Code Academy, but there's another site that one of my friends turned me on to, which I wasn't aware of. Maybe you are, Randall. They're actually located in San Francisco, so maybe we can get a hold of them. But the site is called codecombat.com. And what this is, if you're familiar with like Kingdom Rush it's for kids that are involved with mobile gaming, especially now. So it's very graphically, similar to those types of applications on phones, those games. And what you do is you go in and you can basically go through different levels, and you're fighting bad guys and you're collecting jewels and things like that through all these different levels, but you're doing it through code. So you're writing your code. And this has been tried before, but this is like the first. Well, not the first. It's one of the best implementations I've seen of someone trying to develop this together to get kids into programming, get them interested. And it doesn't teach them necessarily about this language or that language or do it this way. It does teach them object-oriented programming, and it does teach them how to do things like loops and subroutines and things like that. So it's very simple. It starts out, you put a few commands in, and you're off and running. And it doesn't really even give you any instructions. It gives you some, but it doesn't like go into the theory of programming. It just says, hey, why don't you, that little arrow points to it and says, why don't you try writing this? Self.move left. Okay, let's try that, and you just go in and you do it. And I find that that's the best way to learn anyway. So I just wanted to give a little plug for them. And also because I know a lot of our listeners are programmers themselves or work in technology, they might be looking for ways to get their kids into programming. I think it would be a great way to get them started. Also, without taking up too much time, I just want to put a plug in for the makerspace that I run, Benicia Makerspace. You can go to beniciamakerspace.org. If you're in the Northern California area, especially if you're up in Solano County or north of San Francisco and you're looking for a great makerspace, come check us out. This weekend, we'll be making bacon. That's right, making our own bacon. It's going to be a lot of fun. So wow. Please, check us out on our website. It's going to be a lot of fun. We're going to do the curing. We're going to do the smoking, all that stuff. It's going to be great.
Awesome. You should have invited me. I love bacon. Well, who doesn't like bacon except vegetarians and vegans?
Yeah,
and
exactly.
All the and crazy people. That's the only people that don't like bacon. I'll just put them all in the same category. All right. Hey, I'm sorry for running a little over on this show, but there was just such an important topic that I really wanted to make sure we covered it in depth. And Aaron, thanks again for co-hosting the show.
Yeah, you bet. Anytime.
Very good. And we'll see you all again next week on FLOSS Weekly.